Hello everyone, my name is Pranasani and welcome back to this channel. So today we are going to talk about matrix inversion. Starting with what is a matrix, just a general idea what is a matrix. So in mathematics, a matrix is a rectangular array of table of numbers, symbols or expressions arranged in rows and columns. For example, the matrix shown here is of 3 by 3 size. That means it has 3 rows and 3 columns. Some history like the origin of matrix. So the term matrix was introduced by 19th century English mathematician James Sylvester, but it was his friend, the mathematician Arthur Kelly, who developed the algebraic aspect of matrices in two papers in 1850s. Now, what is the need of matrix? Why do we need matrix? So, first point is to represent data as a single object. Now to explain this, suppose if we have a large number of operations to do on lots of different data points, but they all are same operations. So now a matrix can be used to represent that data as a single object. And then matrix multiplication can be used to do the operations. Second is to represent any image. So if you know, every image or video is basically a matrix. The rows and columns of the matrix correspond to rows and columns of pixel, and the numerical entries correspond to the pixels are color values to process digital video and audio. So in the same way, the matrix multiplication can help process digital video, or it can help process digital sound also. Can work with multiple different data. Okay, now suppose that at two different times you take temperature, pressure, and let's say humidity readings. Now those readings could be represented as a matrix as well, with the first set of reading in one column and the second in another. Then multiplying these matrices together results in a new matrix. The numbers in the final matrix might predict the trajectory of a low pressure system. Then the last is to represent data and mathematical equations. So a bit simple, like the numbers in the matrix can represent data and they can also represent mathematical equations. Then we have matrix inverse and requirement. What is matrix inverse? So the inverse of a matrix A is a matrix that when multiplied by A results in the identity, and the notation for this is A inverse. This is the formula, like matrix A multiplied by its inverse is identity. And what are the requirements? Okay, so only square matrices are invertible. That means matrix with the same number of columns and rows are invertible. Second is the determinant of the matrix must not be 0. If it's 0, then it is not invertible. We cannot find the inverse. Then why do we need inverse? What is the need of finding inverse matrix? So the only reason is because we cannot divide a matrix with another matrix. Let's take an example. So here we have to find the matrix X, and the values of two other matrices is given, and this is the equation X multiplied by A equals to B. Now we have the value of A and B, but we need to find the value of matrix A. So you're thinking we can simply just divide matrix A by B, but that is the point. We cannot do that. It is wrong. That is the whole reason we need to find inverse. Instead, what we can do is multiply both sides by A inverse. So if you know, as we shown earlier, a matrix multiplied with its inverse is identity. So in second step, you can see X multiplied by identity is now matrix A multiplied by inverse A. Now if you also know that any matrix multiplied by its identity matrix is a matrix itself, the same matrix. So the final step is that is how we can find the value of A, X, which is equals to matrix B multiplied by A inverse. Now it can be better understand by taking examples. So let's say there is a group which took a trip on a bus at rupees 3 per child and 3.2 per child for a total of 118.40. Then they took the train back at 3.5 per child and 3.60 per adult for a total of 135.20. Now we need to find the number of children and adults that were on the trip. So same, we can take the data and make two metrics, and need to find the third. So we are given with the rate and we are given with the total. We need to find the number. So let's make a matrix of children and adults. This is this matrix for children and adults, and then there's another matrix. This matrix is for the rate. For this is for bus and this is for train, and the final is the total amount. So this is that should be the equation to find the number of children and adults. So the same rule, we are going to find the inverse. How are we going to find? We will be learning about that later. So there are two methods. There are actually three methods. First one is Gauss-Jordan method, row elementary method. Second is adjoint method, and the third one is partial. But we will be learning about that in some another video. So let's talk about Gauss-Jordan method, which is also known as row elementary method. So the elementary row operation are simple things like adding rows, multiplying, and swapping. Let's take an example. So here we have a matrix A, the 3 by 3 matrix, and we need to find the inverse of it. Now we have to turn matrix A into an identity matrix. So the goal is to make matrix A have ones on the diagonal and zeros elsewhere, but we can do only by but we can do only by elementary row operations, which are we can swap rows and columns, we can multiply, divide each elements in a row or column by a constant, or third, we can replace a row column by adding or subtracting a multiple of another row column to it. So then you can see that we have like there are number of operations we perform, and the final goal is to make the matrix an identity matrix, that is the one on the diagonal and zero elsewhere. And the you can see this one is your identity matrix, and we are done. That is Gauss-Jordan method. Second is adjoint method. So we can calculate the inverse of by following steps. So first is by calculating the matrix of minors. Second is then turn that into a matrix of cofactors. Third is then the adjugate, and then multiplying that by 1 by determinant of the matrix. So let's take an example. This is the same matrix we took earlier. Now step 1 was to okay, how are we going to find the minors? So the step is select a element and then ignore that row and column in which that element lies. So here you can see here's an element, and we need to find the determinant of this element. So ignore the row and column of that element and then calculate the determinant of the remaining values, that is 0, 1, minus 2 and 1. So the determinant is 2, and we need to find this process for every element. So that here it is a final matrix of minors. This is a matrix of minors. So the second step is we need to change the sign of alternate cell like shown in the image. So it was the matrix we just made. We need to change the signs, and now this is our next matrix of cofactors. Then the third is transpose. So the matrix of cofactors that we made, we need to transpose its elements. So the basic transpose of element is matrices means that columns become rows and rows becomes columns. Then the fourth and the final step is now we have the adjugate. We need to multiply that adjugate by 1 by determinant. And here we have calculated its determinant earlier. It is 1 by 10. So all we need to do is multiply the adjugate and then multiply it by 1 by determinant of the matrix. And the final matrix is going to be the inverse. And that was the adjoint method of finding inverse of matrix. And thank you for watching the video.